last 2 weeks, we talked about the peer setting. If you haven't checked it, please click the video up here. It's the first one. Today, our topic will be the auxiliary gas in fiber laser cutting. As we know, gas is very important auxiliary helper in cutting. Before I get into the video, please don't forget to subscribe to this channel and give me your like. It helps me out immensely. Thank you for your support. First of all, we need to figure out the role of auxiliary gas. What is it specifically? First, the auxiliary gas can blow away the slags in the coaxial kerf so that the cutting will be clean. Second, to cool the mantle surface and reduce the heat-affected zone. Third, to cool the protective lenses to prevent contamination and overheat so that to cut back the consumables. Fourth, some cutting gases can also protect the base mantle, like we use nitrogen to cut stainless steel against the oxidation. The selection of gas pressure and type has a great influence on the cutting process and the cutting performance, including cutting speed, cutting quality, and other aspects. The quality and the purity of the gas also have a significant impact on the cutting effect. For example, the improper gas pressure may cause slags, and so on. In fiber laser cutting, the most common gases we use are oxygen, compressed air, and nitrogen. Oxygen is more likely used to cut carbon steel. It can form an oxide film, so it will improve the laser absorption capacity of high reflection materials to a certain degree, and there will be a black and shiny cutting section for some oxidizable materials like carbon steel. However, it's kind of combustion supporting gas, easy to burn and generate slags. There will be an oxide film on cut surface, and the oxide film will naturally peel off after a long time, which will affect the welding quality if it needs welding after cutting. Its purity requirements are generally 99.95% or higher. Its main function is to support combustion and blow off the cut melt. The pressure and the flow should be based on the nozzle model and size and the thickness of the cutting material. Generally, the pressure is required to be 0.3 to 1, and the flow rate is different according to the thickness of the cutting material. For example, when we need to cut 22 mm carbon steel, the flow rate should be reached 10 cubic meter per hour. Nitrogen will be applied to cut stainless steel, aluminum, and brass. It's kind of suppression gas, not easy to burn and generate slags. It will have the characteristic of corrosion resistance. The maximum air pressure is relatively large, which can improve the cutting speed to a certain extent. However, it's expensive compared with air and oxygen, and it asks a higher purity and larger consumption. There are high requirements for the purity of nitrogen, especially cutting stainless steel above 8 mm, which generally requires a purity of 99.999%. And the pressure requirements are also relatively large, generally about 1.5 if we want cut more than 12 mm or thicker to 25 mm. The pressure is required to be 2 or higher, and the flow rate varies according to the model of the nozzle, but they are all large. For example, cutting 12 mm stainless steel requires 150 cubic meter per hour, while cutting 3 mm only requires a flow below 50 cubic meter per hour. Compressed air is more suitable for cutting thin metal like less than 6 mm at 8000 watt. the cutting efficiency of thin plates can be compared with nitrogen cutting, which is an economic and efficient cutting method. First is cheap. Except the upfront investment in compressor purchase, the gas is at low cost. The cut surface will form a macro oxide film. It can also support combustion, but it will be less easier than oxygen to burn and generate slags. However, it's not recommended when the cutting requirements are relatively high. If the gas purity is not good, there may be issues occurred. If there is water or oil in the compressed air or some impurities in oxygen and nitrogen, it may cause the protective lenses damaged and the fluctuations in cutting power, which will also lead to inconsistencies in the front and back of the cutting. If the gas purity is higher, it will increase the cutting efficiency, but on the other hand, it will increase the gas cost. Let's take an example. Generally, industrial oxygen purity is 99.9%. Let's say we're going to cut a 25mm carbon steel. If we enhance the purity to 99.99% or more, the cutting exhibition will be much better and a 10% cutting speed raise is possible. So the auxiliary gas is related to our requirements, mental thickness, purchase budget, and other factors. And we also need to set suitable pressure to perfect the cutting. Click the video up here. You can find a reference gas pressure setting from 100 watt to 8000 watt. Do you have other questions on the auxiliary gas? Please write it in the comment below. I would like to learn more. Thank you for joining here today. Please don't forget to subscribe me. I will see you next Tuesday here on my YouTube channel. See you. Bye.